Edbook worms, hi! Thanks for joining me again in this video. We will be continuing with our section on work. Yes, grade 12s, we are still on work, energy, and power. And we are just taking off from where we left off in the first video. Now, just a quick run through of what we spoke about in the first video. We spoke about we defined work, and then we talked about the different types of forces that do work. We spoke about forces that are parallel and in the same direction as the displacement, or rather motion, however you put it, of the object. And we also mentioned that we use cos of 0 for those forces that are parallel and in the same direction as the displacement of the object. And we also define that these forces do positive work on that object. Now, just to elaborate more, it's not only forces that are parallel and in the same direction as the displacement of the object, but rather forces that act at an angle that are less than 90 degrees. Forces that act at an angle of less than 90 degrees to the horizontal or displacement of the object do positive work. We also spoke of forces that act perpendicular to the motion or rather displacement of an object. We said that these forces that are perpendicular, they do no work on an object, because as we quickly remind ourselves of the requirements for a force to do work is that first of all, there has to be motion in the direction of the applied force. And secondly, there has to be motion. There has to be motion. The object has to move, as well as it has to move in the direction of the force that is applied. So as we said, if a force is acting perpendicular to the motion of an object, then that force does no work. We also spoke of forces that do negative work. An example that we gave was frictional force, because we know that friction works, or rather friction is the direction of friction rather. The direction of friction is in the opposite direction to the motion of an object. So friction always does negative work on that object. Now, as you will see in the problems that we will be doing in this video, it's not only friction that does negative work. There are also other types of forces that do negative work on an object. And we also concluded by saying that friction, since, well, it does negative work on that object, in our calculations we use the cos of 180 degrees. Now, in this lesson, we will be looking at three types of work problems. The first two aren't really problematic. It's the third one that really gives people a headache, that gives learners much a headache. Now, the first type of problem that we look at is the one that involves a force that is parallel and in the same direction to the displacement of an object. For example, my hand is exerting a force that is parallel to the displacement of an object, and this force is in that direction. I know that you recall that I demonstrated this in the first video. The second type of a problem is when you have a force being exerted on an object at an angle to the horizontal. The horizontal, we mean the plane at which the object is moving along. Now, as you can see, this would be a force being exerted parallel to the horizontal. However, this time my hand is exerting a force in this direction, okay? So the tension force is in that direction and it's being exerted on the object. That's also another type of problem that we will be looking at today. The third type of a problem is when you have a force acting parallel to an inclined surface. That's where you have an object moving along an inclined surface, and then you have to calculate the work done by the various forces that exist in this type of situation. Now, we have done the first problem. The first problem being that looking at forces that are parallel and in the same direction to the displacement of the object. We did that in the first video using my hand as an example, exerting a force of 3 newtons over a distance of 2 meters. We've done the calculations already. Let's rather look at this type of a problem. Okay, let's say you have this block and it's being pulled over a distance of 5 meters at an angle of 60 degrees. Now, the force that I'm applying is 10 newtons, okay? So let's say from here to here, that's our 5 meters. I'm exerting 10 newtons at an angle of 60 degrees to the horizontal, okay? So that's our case study. How do we go about that? Okay, this is how it goes down. In our calculations, we look at the work done by the applied force. The applied force being the force that I applied, which is 10 newtons. Now, from the equation that we unpacked the other day, we said that our work is equal to our force times the displacement cos P, or theta, or whatever you want to call that angle. Let's rather call our angle P for now. So our equation is W is equal to F delta X cos P. Now, what are we calculating here? We are calculating the work done by the force I was applying. That force of 10 newtons at an angle of 60 degrees. So what is it that we have? We are given our force, which is 10 newtons. We have our angle, which is 60 degrees. We know that this force is acting at an angle of 60 degrees to the horizontal. What else do we have? We are given our displacement, which is 5 meters. All we do is simply to plug into our equation. So we have our 10 newtons going into the being substituted in the force variable. The displacement goes in there, as well as our angle goes there. Eventually, we have 10 times 5 cos of 60 degrees. We end up with 25 joules as the work done by the force I was applying. Now, consider that in this type of a problem, we also have a frictional force of 4 newtons being exerted by the table on the block. Now, if we were to calculate the work done by friction, then we would say, going back to our equation, we have W, F delta X cos an angle. Now, we already know the magnitude of the force that's being applied. It's 4 newtons. Our frictional force is 4 newtons. There we have it. Our displacement is still 5 meters. There we have it. Cos of 180 degrees. Because even in the previous video, if you recall in the previous video, we said that friction does negative work. Hence, we use cos of 180 degrees because it's in the opposite direction to the displacement of an object. Now, if we substitute all our values, that's 4 newtons times 5 meters, cos 180 degrees, we then get minus 20 joules. So overall, if we were to calculate the net work done on this object, the total work done on this object, it would be all the work done by all the forces acting on the object, okay? All the forces that are doing the work on the object. So the forces that are doing work on this object, the applied force and friction. We don't consider gravity because gravity is perpendicular to the motion of an object. We don't consider the normal force because the normal force is perpendicular to the motion of the object. So the total work done on this object will be the applied force plus your friction, which is 25 joules minus 20. So the net work done on this object is 5 joules.